One of the most essential parts of creating a 2D game is of course player movement. And even though it's one of those basic mechanics that we often take for granted, creating a really good player controller can actually be quite challenging. In fact, it's something that even experienced programmers can spend weeks or even months of development time getting to feel just right. Of course, everything depends on what you want your character to do. Can he jump? Can he be controlled in air? Can he crouch? Can he wall run? Does he slide down ledges? What about animation? And so on. Now that might sound a bit overwhelming. But as always with game development, there are ways that we can cheat a little bit. If you're just starting out, I really recommend finding a good character controller online, simply because you don't want to be stuck doing movement when there are so many other aspects of game development that you should explore. Also, this video is sponsored by Skillshare. Skillshare is an online learning community with more than 21,000 classes on game development, tech, and more. And since this is a 2D video, I thought I would introduce you guys to an awesome course on creating a bone-based 2D character in Unity. This beginner-friendly course is made by game developer Vladimir Limachenko, and it comes with 3 downloadable characters to help you get started. A premium Skillshare membership gives you unlimited access to all classes for less than $10 a month. So to get started, simply click the link in the description, and the first 500 people will receive their first 2 months for free. Now, a character controller is basically just a script that takes care of all of the more advanced physics calculations that go into making your character move. So by using one of these, we can focus on writing a much simpler script that will just tell the character controller what to do. For the purpose of this video, I've of course gone ahead and prepared a character controller that we can use as a base. But enough talking about it, let's give our player some moves. Yeah! So we're here in Unity, and I've gone ahead and set up a simple 2D scene using the Sunnyland asset from the Unity Asset Store. I'll of course have a link for that in the description. There's not much in here. There's currently just a player which has nothing on him other than a sprite renderer, as well as a main camera, of course some different tiles making up our level, and I've gone ahead and placed colliders on the platforms as well as the ground. And then we have a few background elements. So since we're going to be using a character controller to help us with our movement, we of course first have to get it into Unity. Mine is right here on the desktop. I'll of course have a link to where you can download the script as well as the entire project. So I'm just going to take this and drag it into Unity. And right away, let's select our player and drag our script on there. If we have a look at the different variables that are in our script, we can see that we can adjust a bunch of different things that has to do with our character. First of all, we have the jump force. I'm just going to set this to a value of 700. We then have the crouch speed, which we can adjust using a slider here. And this is basically how much we want to slow down when crouching. I'm just going to set this to something like 0.4. And so we're going to be moving at 40% speed while we're crouching. We can also adjust how much we want to smooth out our movement. I'm just going to leave that as is. Whether or not we want to be able to control the character in air, which I definitely do want to. And then we have to define this what is ground variable. And this basically just allows us to choose what layers we want to act as a walkable surface for our character. I'm just going to set this to everything and then go back in and remove the player layer, because we don't want our player to be able to walk on top of himself. I'm also going to go to the top and change his layer to player. And then we have these 3 empty slots. The first 2 are what we call checks. And we use these to check whether or not we're currently standing on the ground so that we can determine whether or not we can jump. And if we're crouching, we want to know if there's a ceiling above our heads in order to determine if we can actually stand up again. And to make things simple, we're using these empty objects to determine where these locations are. So let's go in and create these objects. Let's right click on the player and let's hit create empty. And I'm going to switch to the move tool here by pressing W. And now we can see where the empty object is. I think this is pretty close to our ceiling check, but I'm just going to go ahead and move it up a tiny bit. Something around here. I'm then going to duplicate it by pressing Ctrl D and move this one down to the feet of our character. I'm going to rename this one to ground check and the other one to ceiling check, just to stay organized. We can then select our player and drag our ground check into the ground check slot, and the same thing for the ceiling check. The last variable here, the crouch disable collider, we'll talk about later. But our character controller is now set up and should work just fine. However, there are a few more components that are required in order to make our player work. The first one of these is of course a rigid body, because this will enable physics for our character. So let's hit add component and let's search for rigid body 2D. We can then open up this component, and the first thing that we want to do in here is probably bump up our gravity scale. In general, it feels nicer if your character has a larger gravity than other objects. It makes stuff like jumping feel more snappy. I'm gonna set mine to 3, but you can of course experiment. We also don't want our character to be able to rotate at all. We simply want him to move around the level, but always have him facing upwards. Because of this, we can go under Constraints and freeze the rotation on the Z-axis. And now he should stay the same at all times. Finally, we need to go in here and add a collider for our player. Because right now if we play the game, we can see that he simply just falls down. But it can actually be a really good idea to use multiple colliders when you're working with a player. This can help smooth out collisions or make them feel more realistic. One fairly simple setup that I really like is using two colliders, a circle collider and a box collider. Let's start by creating the box collider. So we'll go in here and add a box collider 2D. Let's open it up and we should now be able to see it. However, the background makes it pretty hard to see. So I'm just going to go under my main camera and disable the background for a second. And now when we select the player, we can clearly see the green bounding box. I'm going to hit F to focus on our player. I'm then going to press Edit Collider. And we can now scale our collider to fit our player. One thing that I recommend is holding down Alt to scale on both axes. One of the reasons for this is that we don't want any offset on the X-axis, because since we are flipping the character, that's going to make the collider behave really weird. So I'm just going to bring this in, and I'm also going to bring it down on the Y. And finally, I actually want to completely remove this collider from the feed of our character. And that's because I found it works much better to use a circle collider here. So I'm going to stop editing this collider and add a circle collider as well. Circle collider 2D. Let's open this up as well. And we can see right now it isn't really positioned in a way that we would like. So we can of course go in and offset it on the Y here, as well as press Edit Collider and kind of bring it in. And I'm going to go ahead and move it up a tiny bit more. And if you slide on a value like this in the inspector while holding down Alt, you'll be able to fine tune much more neatly. Something like that looks pretty good. I'm actually going to adjust the radius to be just a tad larger and bring it up a tiny bit more. And finally, I'm going to take the box collider and bring it down a tiny bit and inwards a tiny bit. There we go. Let's stop editing the collider and we now have these two overlapping colliders. And you can already kind of see what the benefit of this is. Because say we want to move up a slope like this one, if we were only using a box collider, it would take the edge of this collider and kind of push it towards the slope. However, since we're using a much more rounded shape, our movement is going to feel much cleaner when moving up the slope. And that's actually another reason which has to do with crouching, but we'll see that later. So let's move our player back up, and if we now hit play, we can see that immediately our player falls to the ground and he's ready to start moving. So let's stop playing. Let's re-enable the background here. Let's select the player. I'm just gonna close all of these components and let's add our player movement script. Let's hit Add Component, search for Player Movement, select New Script, create an ad, and let's double click it to open it up in Visual Studio. And the script that we're going to be creating here is fairly simple. And the very first thing that we want to do is get a reference from our player movement to our character controller 2D, so that we can tell this script to move our character. To do that, at the very top of our script, we'll create a public character controller 2D variable, and we'll simply call it something like controller. If we then save this and go into Unity, we can see that we now get this empty slot called controller, where we can drag in our character controller script. And now every time we write controller in our movement script, it's referencing this particular script. So if we were to go in here and write controller.move, well, this would go ahead and move our character. But of course, we can't just tell it to move. We need to specify where we want to move, both in what direction and at what speed. So to do that, we need to get some input from the player. And every time we get input from the player, we use the input class. So I'm going to write input dot, and then we're going to use a function called getAxisRaw. And the axis that we want to get here is the horizontal axis. Now what this is basically a value between -1 and 1 that is going to change depending on the user input. If we press the left arrow key or the A key on our keyboard, this is going to be -1. If we press the right arrow key or the D key on our keyboard, this is going to be 1. And similarly, if you're using a controller and press the thumbstick all the way to the left, it's going to be -1. And to the right, of course, it's going to be 1. So this simply gives us a value that determines where we want to move on the horizontal axis. To kind of show you this happening, I'm just going to use a simple function called debug.log. and this will print out a message to the console. In other words, we can simply display our input here inside the editor. So if we just write out this piece of code here and save it and then hit play, we can see that in the console here we get a bunch of messages saying 0. However, if I then press my left arrow key, we can see that it says -1, and if I press my right arrow key, we can see that it says 1. So now we have a way of detecting input. I'm gonna get rid of the debug.log here, and we could use this input to move our character right here. But it's not recommended to move a character inside of the update method. Instead, we want to use another function that is dedicated for physics. This function is called fixedUpdate, and it works in much the same way as update. However, instead of being called once every time the computer draws a frame on the screen, it's called a fixed amount of times per second, hence fixedUpdate. So let's just go ahead and create this function. I'm going to write void fixedUpdate. Let's open and close two parentheses and some curly brackets. And this is where we want to move our character. So in general, when it comes to movement, we can say that we use the update method to get input from our player, and we use the fixedUpdate method to apply that input to our character. We're not really using the start function here, so I'm just going to remove that. But we of course need to get this input from one function to the other. And to do that, we need a variable. So at the top here, I'm going to write float. And let's create a variable called something like horizontal move. And by default, we'll just set that to 0. Then inside of our update method, we can set horizontal move equal to the result of our input. And we'll close that off with a semicolon. Then when we want to actually move our character down here, we can write controller.move. And this of course takes in a float determining how much we want to move. And we want to move according to our horizontal move variable. And let's then close that off with a semicolon. However, our move function actually also takes in two other variables. The first one determines whether or not we should crouch, and the second one determines whether or not we should jump. Right now we'll just say no to both of these, so we'll write comma and then false, saying that we don't want to crouch, and comma false, saying that we don't want to jump. But we'll of course implement both of these in a sec. Also right now we're moving our character in the right direction, but we don't have any control over the speed. So let's just go to the top here and create another public float, and we'll call this one the run speed, and set it to something like 40 by default. Then when we get the input from our player, we'll go ahead and multiply that input with a run speed. So that if the player wants to move to the left, the horizontal move will be -40, and to the right will be 40. And the final thing that we need to do in order for this to work correctly is whenever we're telling our character to move, we actually need to multiply that movement speed with time.fixedDeltaTime. Now time.fixedDeltaTime is the amount of time that elapsed since the last time this function was called. In other words, multiplying with time.fixedDeltaTime is going to ensure that we move the same amount no matter how often this function is called. So that if this function is called 60 or 100 times per second, doesn't matter, our character speed is still going to be consistent across all systems and platforms. And now this should work, so let's go ahead and save this. And inside of Unity we can now see our run speed, which we can adjust here if we want to. Let's hit play, and we can now move our character back and forth inside of our level. You'll also notice that every time our player falls, he kind of shifts into the ground a little bit. To get rid of this, we can go under rigid body and change the collision detection from discrete to continuous. And this should make sure that he never kind of goes into the ground in any way. So now we're ready to make our character jump, and this is actually really easy compared to normal movement. All we have to do is check whether or not we press the jump key. So we'll write if input.get button down. So if we press down a certain button and the button that we want to check for is jump, well then we want to go ahead and jump. And of course, again, we want to jump inside of our fixedUpdate function. So we have to kind of transfer this information down here. And again, the best way to do that is using a variable. So up here, we'll now create a Boolean, and a Boolean can of course only be true or false. And we'll call this one jump, and we'll set it to false by default. And then if we press the jump button, we're going to set jump to true. And then down in our fixedUpdate, instead of saying always false, we never want to jump, we can now just pass in our jump variable. So that if we press this button and jump becomes true, we go ahead and tell the controller that we want to jump. And of course, right after that, we want jump to become false again, so that we don't keep on jumping forever. And if we save that and go into Unity and hit play, we should now be able to move around. And whenever we press space, voila, our character actually starts jumping. Super cool. Also, there's currently a quick problem that we need to fix. That is, whenever we try and jump and then move towards a platform, we can kind of get stuck on it. Of course, this is not something that we would like. We want to simply slide off and then fall down. To get rid of this issue is luckily super easy. All we need to do is create a physics material. To do that, we'll go to our project and hit create, and we'll then select physics material 2D. And we want to create a really slippery material so that we will simply slide off. So let's just call it slippery. And in here we can adjust two settings, the friction and the bounciness. We want the bounciness to remain at 0, and we'll also set the friction to 0 as well. Then if we select our player, we can take this slippery physics material and drag it into the material on our box collider. And now when we play the game, we can see that we slide right off platforms. We can still get stuck on the very corner of the circle. If this happens or not is going to depend on the way you've set up your colliders. In our case, we can simply go ahead and add the slippery material to there as well. And you can now see that we fall right off of platforms. And at this point, some of you might be wondering, well, we just wrote jump. Why does this jump variable correlate to space? And why does horizontal mean A and D and left and right? Well, this is actually something that we can configure visually, because inside of Unity, if we go to Edit, Project Settings, Input, we see the Input Manager. Here we have the horizontal axis. You can see it's called horizontal here, and we can see the different buttons here. There's left and right arrow key, as well as the A and D key. So you can go in here and change it if you want to. And there's also one in here called jump, which currently has space as the positive button. If we wanted to jump on, say, W, we could simply write W here instead. In fact, let's try right-clicking on this jump entry here and hit duplicate array element. This is going to go ahead and create a new button configuration with the same settings. Let's rename this one to crouch, and instead of W, we'll use the S key. Of course, if people want to control the character using the arrow keys, we can set that up as well. We'll just create an alternative positive button. So here it will be up for jumping, and here it will be down for crouching. So now we've set up all of our input, and we're ready to make our character crouch. And doing this is almost as simple as jumping. We go into our update, we write if input.get button down. And the button that we want to look for now is the crouch that we just created. And if this button is pressed, well, then we want to go ahead and crouch. So let's create a variable for that up here. It's also going to be a bool. Let's call it crouch, and let's set it to false by default. Then if we get the button down, we'll set crouch to true. And now down in our fixed update, instead of just passing in false, we'll put in our crouch variable. Of course, crouching doesn't work in the same way as jumping. We don't want to just quickly crouch and then stop. Instead, we want to stop crouching when we release the crouch button. In other words, we only want to crouch while holding down crouch. Luckily, we can also register whenever we release a button. To do this, let's go to the update function and let's write else if. So if we don't get a button down, we might get a button up. So we'll go input.get button up. And again, the button we're talking about here is the crouch button. And if we get a button up here, we'll set crouch to false. So now if we save this and go into Unity and hit play, we should actually be able to press down in order to crouch. However, you will really not see anything happen here. The reason why is that crouching is of course something that we display with an animation, and we don't have any animations on our character. However, we should see that if we move and then try and crouch and move, we move at a much slower pace. So it is indeed working. We can go between crouching and normal movement, and that works just fine. However, one thing that we also need to happen when crouching is of course the ability to duck under obstacles. For example, this platform here. If I currently select the player and we make sure that gizmos is enabled at the top here of our game view, let's open up our circle and box colliders, we can actually see them here. If we then try and move onto this platform, we can see that we're currently too tall to get under it. That's because of this box collider right here. What I've gone ahead and done is under the character controller 2D, I've added this crouch disable collider, so that if you set up your colliders in the same way that I have, we can simply take the box collider and drag it in there. And now whenever we crouch, the box collider is going to be disabled. And so we're only going to be using the circle collider. In fact, we can kind of see this happening. If I now press crouch, we can see that the box disappears. And if I try and crouch my way under the platform, it works. We can also see that if I try and stop crouching, so now I'm going to release the button, while under the platform it's not going to work. And that's because we've set up our ceiling check correctly. So it's registering that there's something above us, and so we don't want to be able to stand up until we get to a point here where there's no longer something above us, and so we'll stop crouching. That's super cool. Of course, this currently looks a bit silly since we don't have the crouch animation, but you can see that behind the scenes everything is working as it should. And that pretty much includes this first ever character controller. From here it's completely up to you to try and expand upon it and edit different settings to get the controller feeling the way that you would like it to. Of course, this character could really do with some animation, and animation is something that's really fun and simple to add, so if that's something that you guys want to see, definitely leave a comment down below. Yay! That's pretty much it for this video. If you enjoyed it, make sure to subscribe and ring that notification bell so you don't miss the next one. Also, if you haven't joined already, make sure to check out the Brackeys Discord channel. It was created by some awesome guys from the forum, and it's a great place to talk to other developers, get feedback, or just hang out. You can join now by using the link in the description. Also, make sure to check out Skillshare. Simply click the link in the description to get started. On that, thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in June, and a special thanks to Michael Neely, Clinton Van Skewer, Andrew Kalinenko, Cheetah3D, Alexander Blair, Cyborg Mummy, Jeff Paulson, Dennis Sullivan, Superman the Great, Faisal Marify, Derek Heemskirk, Fang So Long, Leo Lisette, Tim of Holderbach, Adrian Haslinger, James Rogers, Rob Farron, Gregory Pierce, Naoki Iwasaki, Larry Tweed, Erasmus, Bruins Cat, Fabrizi, Corey Jackson, Kirill Svitoski, James P, and Robert Bund. You guys rock!